from limits. So I hope you can see the problem clearly. So yeah, the function is defined in the following way. F of x is x plus mod x into 1 plus x divided by x times sine 1 by x when x not equal to 0. So L is the left limit of f of x at 0. So limit x tends to 0 minus f of x, and R is the right limit of f of x. The problem is to find whether L exists or not and R exists or not. That's the problem. So how do we approach problems like this? So we need L, right? So I will simply write L, which is left limit x tending to 0 minus f of x, which is, yeah. Now can you tell me what should I write? So what is f of x when x approaching from the left hand side of 0? So our function is x plus mod x times 1 plus x. So what is mod x here?
Minus x.
Right. So because we are approaching to 0 from the left, so mod x is minus x times 1 plus x divided by x times sine 1 by x. Now you can simplify it. So I think maybe I will directly write it. So we can, when you simplify the numerator, what happens is that 1x will cancel, and then I think you get something like minus x sine 1 by x, right? Now,
Yes, sir.
yes. So now, yeah, whether this limit exists or not, any idea?
The squeeze theorem.
Okay, so you think this exists. Okay. And what will be the value? Any? So we are talking about
Zero.
x. Yeah. So yeah, you can use Q's theorem, or maybe I will write another way. So that is, we want this quantity x sine 1 by x. So yeah, if you take the modulus of this, you can see that this is less than or equal to mod x times sine is bounded by 1. So this inequality tells you that as x tending to 0, this mod x tends to 0, right? As x tends to 0. So this tends to 0. Right. So this is one way to say, or yeah, Q's theorem, it's the same thing. So this limit is 0, and that means the left limit exists. We just need to know whether it exists or not. So the limit exists. So that's what we need to know. Now, how about the right limit? For right limit, what you want is this. So limit x tending to 0 plus. So here mod x is x, right? So okay. So these are simple calculations. That's why I'm not explaining much. So now what happens when you simplify? I think you get x plus 2 times sine 1 by x or something like that. Right? You can check it. So now, yeah, any idea whether about this, whether it exists or not? Maybe we can split. Yeah, we can split this into two as follows. So maybe I will write it in another page. Yeah, we got limit x tends to 0 minus x, which is x plus 2. Yeah, x plus 2 times. So maybe we can write this thing as x sine 1 by x plus 2 sine 1 by x. Now, yeah, so we already discussed this limit exists, right? The first one tends to 0 as x tends to 0. Now, how about the other term, sine 1 by x, 2 sine 1 by x, whether the limit exists? I didn't hear. Does it
No,
exist?
sir.
Yeah, any reason for that? Like some, there are many ways to argue that, but you can say sequentially you can argue. So maybe, yeah, I don't know, like, so this doesn't exist because one way to see it is, so you know the sequential criterion, right? So if limit x tends to a f of x equal to L, then this is if and only if for any sequence, I'm not writing the full sentence, but tending to a, you need f of xn to converge to the same limit, same value. So this is a sequential criteria. This is one way to argue. So in what happens with sine 1 by x is that we are looking at limit tending to 0. So you can take xn to be, say, 1 by n pi. So when you this tends to 0, now when you put it in sine of 1 by x, you get sine of n pi, which is 0 for every n. So this tends to 0. So some other sequence you can take, say, something like 1 by, so the other type. So maybe like 2n pi plus pi by 2 or kind of. So this is also tends to 0, but when you apply it in sine 1 by x, you get sine 2n pi plus pi by 2, which is 1. So it tends to 1. You get this tends to 1. So you get two different values. So that means it will not satisfy this criterion. So that is one way to argue. I mean, there are many ways. So I just want to remind you of that. So yeah, so that is what we got. So that's why this one limit exists. So what we got is the following. So this is 0. This doesn't exist. We want to talk about the sum of them, right? So can I say the sum doesn't exist, or is it always true? If some limit exists and some limit doesn't exist, when we add them, but can we say it doesn't exist always? Any idea? So you know the following. You have the algebra of limits, right? So generally you have this result. Limit, say, x tends to a f of x plus g of x. You have this formula. Limit x tends to a f of x g of. You can do this provided you know that this limit
Both
exists
limits.
and this limit exists. That is what you know from the limit property. So here the situation is different. That is, you have two terms in which one limit exists, the other one doesn't exist. So my question is, can I always say that when I add them, this doesn't exist? Or is there any cases when in some cases it exists? So you know about, are you aware about that? Or, so if not, I will just simply explain. So the answer is it always doesn't exist. So if you have some function whose limit exists and some other function, so I will simply write it. So suppose f of x limit x tends to a. Suppose this is L, limit exists, and g of x doesn't exist. Suppose now I can always say this, the following. So now the question is whether f of x plus g of x exist or not. That's the question, right? So we can prove by contradiction. So suppose the limit exists. Suppose limit of this. I'm not writing extends to a. I think it's understandable from the statement. So suppose this limit exists. Say some L prime. L prime. Then what happens is that you know that f of x also exists. Limit f of x also exists. So from the algebra of limits, you know that this limit also exists, right? Because this can be seen as sum of two terms or difference of two terms where both limit exists. So that would mean that this limit exists and the value is L prime minus L. But that is a contradiction because what is this? This is just g of x. We assume that g of x limit doesn't exist. So this is a contradiction. So that is how we prove in general. So generally you can always do this. So if you have a limit which exists and then doesn't exist, when you add them, it always doesn't exist. I mean, so I just want to make that point. Why is it true? I mean, generally people don't care about this. They just simply say it doesn't exist, but this is the reason. So I hope you understand it. So I will move on to another problem if everyone got the idea. So yeah, I think I can move to other. Okay. So yeah, this is another problem from. Yeah, mainly I have collected problems from this limits, continuity, differentiability, and some one or two problems from related to Riemann integration. So yeah, let us see how this problem goes. So let us see what is given to you. So if every time when you see a problem, just look at the conditions given to you. So it's very important. So what is given? F from R to R is a differentiable function. F of 2 is 2. That is the information given to you. Another thing is this inequality is given. F of x minus f of y modulus is less than or equal to this 5 times mod x minus 5 or 3 by 2. Now you have given another function, say g of x, which is x cube f of x. Then they are asking about the derivative of g at the point 2. So that means g is defined in using f. So x cube f of x. That means you should know what derivative of f is. So can you from this conditions can you get some information about the derivative of it at some point or at all points maybe? Can you use this inequality to get something? I mean, these kind of problems are common nowadays. If you have experience in solving problems from previous year question papers, whichever, not just IIT JAM or anything, you must have seen these kind of problems. So if you are seeing it for the first time, maybe it feels non-trivial, but yeah. So any idea how can we use this? So this is the inequality, you know. This is, the interesting is this is true for all x and y in R, not just for some x and y. It's true for all x and y. So any idea?
We
Divide by
can
mod
divide.
x minus y.
Okay, so yeah, that is what made you think that way? Because we want the derivative, right? So
Yes, sir.
yeah, so we do that for a reason. Otherwise, we don't do that. So we want the derivative, so we know that derivative is coming as limit of these guys. So that is why you divide it by x minus y. So yeah, for all, yeah, x not equal to y. For x equal to y, that doesn't make sense. So for all x not equal to y, x, y in R, you have this inequality. So now what can we say? Any? So yeah, what we got is modulus of f of x minus f of y divided by x minus y is less than or equal to 5 times. sorry, 1 by 2 for all xy. So will it give any idea about derivative of f at some point or any point?
We can find the derivative at x.
Yes. So how do we find from this inequality?
For if we take y tends to x, then it will the left hand side will give mod of f dash x, and right hand side will go to.
Yeah, right. So yeah, so I will, so because it's coming in x and y, maybe I will simply pick an arbitrary real number. We will see what f dash a is. Your idea is correct. I am just explaining. So we need to find the derivative. So what inequality we know is this. So fix an a in R. So we have this inequality, right? I am writing a because generally that's what we do, right? We don't use y. We use y for variable. So in order to avoid confusion, I am writing a. So we have this inequality. So this is true for all x, right? Not equal to a from the above statement. Now, as she said, when x tends to, so what we need is the limit of this guy, right? As x tends to a. We want to see as x tends to a, where does this go? That is the value f dash a, right? That is by definition, f dash a is limit of x tends to a, f of x minus f of a by x minus a. So that is why we are doing this. Now, from this inequality, what can we say about as x tends to a, where does this go? That term, you can see the right side, this thing tends to 0, right? As x tends to a mod x and say power half. So you can say this also tends to 0. That means here a was arbitrary. So whatever a I take, I am getting f dash a is 0, right? So this function has the property that derivative is 0 everywhere, which means what is that function?
Constant function.
Yeah, so f has to be a constant. Can you tell me what that constant is in this case?
2.
F is equal to 2, because it is given that f of 2 is 2. So that means that constant must be 2. So in this case, our f is nothing but the constant function 2. Now you have nothing to do, right? So now you can find. You found f of x, which is 2. So g of x is nothing but 2x cube. Now you can find g dash 2. So that you can find. I hope you got the point. So can I move on to another problem?
Yes, sir.
No, I have included a similar problem just for experience. So it's similar, but not exactly the same. So again, so one thing which I want to say in this problem, see this condition of differentiability, which was not required, which was we already got it. We didn't use it. We already got it, that limit exists and tends to 0 always. So it was not required, but yeah, in the problem it was there. So yeah. So in this problem, let f from 0, 1 to r be a continuous function, such that this is another condition that you have, and you have another inequality given. Maybe I will write below. This is true for all xy in the domain. Here domain is 0, 1. Now they are asking about integral, but so integral of f of x. So you need to know some information about f of x. So what do you do in this case? How do you get f of x from? Can you get f of x from this inequality or something like that? So because we have seen a similar problem, you should be able to No.
Dividing both sides by mod x minus y.
Yes. So when we do that, what happens is that, so x
And
minus y go inside. So this is minus 1. Is it coming? Is right when you divide by x minus y?
yes,
Yeah. So yeah, now you got a nice inequality. So now again, you should be knowing what to do, right? Maybe you can write x tends to a or whatever. So what when you do the same calculation, so what happens to the right hand side? This tends to 0, isn't?
it will go to 0.
As x tends to y, right?
Yes.
This time I am writing y because I don't want to write it again. So as x tends to 0, as x tends to y, why this tends to 0? Any?
So if we multiply mod of x minus y in denominator and
Yes.
then sin mod x minus y square by mod x minus square is tends to 1, and
Exactly, exactly. So yeah, I got your idea. So this is what you are saying. So there are two terms. So you multiplied numerator and denominator by mod x minus y. So so if someone doesn't understand this, they will be wondering why we multiplied it, right? So there should be a reason. It didn't come from anywhere. It didn't come from nowhere. You did it for a reason, right? Because you know that this limit exists. Sine say limit x tends to 0, sine x by x, that is 1. It's in a similar form. That is why you did that. If someone doesn't know that, then no one, they are not going to do it, right? So because you know about this limit, sine of something by something, where that something is tending to 0, so this term tends to 1 and this tends to 0 as x tends to y. That is why altogether this tends to 0 into 1, which is 0. That's how you got this right hand side tends to 0. So yeah, so that means this thing tends to 1 from this inequality, right? So that, what does that tell you? F dash x is 1 for every x. So regardless of what x is, we are getting it, that limit is 1. So for every x we are getting this f dash x is 1. So what can you say about f of x then, if f dash x is a constant or f dash x is 1? So we want f of integral 0 to 1 f of x, not f dash x. So we got f dash x. How do you get f of x? So in the last problem, we had f dash x is 0. You said it's constant. So similarly, is f dash x is 1, what do you do to get f of x?
Integrate, sir.
Yeah, so f of x is x. Is it x or there will be a constant, right? So
X
don't write it
specific.
is x. So this is the function. Now, can you find this c from the information given?
yes, sir.
Yes, sir. Given that f of 1 by 2 is equal to minus 1 by 2.
Yes. So f of 1 by 2 is given to be minus 1 by 2. When you put that in the equation, you will see that c is minus 1. That you can check. So that means the function we are talking about is this function x minus 1, right? So they have given a what big condition on some function, but what we proved is that f of x equal to x minus 1 is the only function satisfying this, right? Now what we need is integrate them in 0 1. That I'm not going to do because you can do it, right? So yeah, it's all about finding that f of x. Using this inequality, we found it. I hope you got the idea. So we move to another problem. So if you not get didn't get anything or you have any doubt, please ask. Otherwise, I won't know. So yeah, so we will go to another problem. Yeah. So read the question carefully every time. Whatever conditions are given, you shouldn't miss it. Everything should be taken carefully. Like and means here f is a function from r to 0 infinity. It's a continuous function. Which of the following are not true? That is the main thing you should see, because sometimes it's a general tendency to uh, find the options which are correct and we will mark it. And I am not saying this is MSQ or MCQ, because this is, I mean, you should see any question as MSQ type. That's how you should approach. I mean, the exam, if you have an MCQ question, you can eliminate the other three options and do that. But when you prepare or when you practice problems now, you always see it as an MSQ problem, so that you should address each options. You shouldn't avoid some options. So that's what. So in this problem, you need to find which of the following are not true. Okay, we will see what they are given. So yeah, the first option says there is an element in R such that f of x is f of 0 plus f of 1 by 2. So any idea whether such an element exists? If you want to disprove it, you have to come up with a function, continuous function, which doesn't have this property. If you want to prove it, just give some using some result or something. Can you say? Always say. So f is given to be some function from r to 0 infinity. It could be anything. It's a continuous function. So they are asking, they are given f of 0 is given f of 1, some value. We don't know what is f of 0 and f of 1. They could be same or different. So they are asking, always there will be a, yeah. Any idea?
Intermediate value theorem.
Yes. So that is the idea. So that means, what do you know about this number f of 0 plus f of 1 by 2? This always lies between, I can't say f of 0 and f of 1, but because it depends on which is bigger, but still I write it. So f of 0 or f of 1 on left or right depends on f of 0 or f of 1 is bigger. So this is always lying between these, right? So and in maybe they will be, they are equal. There can be cases when f of 0 is f of 1. In that case also, this average, we are taking basically arithmetic mean. So that average will be itself. Then also you will get a real number. So here in general, we have this inequality. So in fact, there is an x in between 0 1. In fact, close interval 0 1, such that f of x is f of 0. So that is by intermediate value property. So you should know intermediate value property, intermediate value theorem, and the fact that this lies between f of 0 and f of 1. That's what we are using. Okay, so this is a true statement. So this cannot be taken as an answer. Now, what about the second problem? Root of f of minus 1. First of all, the function is defined, the codomain is 0 infinity. So it makes sense to take square root of that. It is well defined. Now, so can we say this? Is it true? Can we always say there is a real number such that f of x?
Yes, sir, by IVT theorem.
By what theorem?
IVT.
Oh, IVT. Okay, intermediate value theorem. Yeah, I mean, again, what's the reasoning? I mean, why did you say that?
So this is geometric mean of f
Yes.
of 1 and f of 1.
Yeah. So this is lies between, this is geometric mean, which, so This is less. This, see, I am writing f of minus 1 and f of 1. Depends on whichever is bigger, you need to write on the right, and whichever is smaller, you need to write on the left. And just right. So yeah, same reasoning, right? So that is the idea. So in between minus 1 and 1, you always get a number which is this. So that's the idea. So this is also true. So true statement. So you can't take this as an. What about other two options? There is a real number such that f of x is integral minus 1 to 1 f of t. Or
The
there
second option is not clear to me.
second option. Okay. So you got the first option, right? It is basically the arithmetic mean of two things, which you know it lies between that two numbers.
Yes, yes.
Similarly, what is the root of product of numbers? That is a geometry mean, right? Root of AB.
Yes.
So it always lies between A and B, right?
Okay, okay. That's
If you are you confused, or that always lies between A and B. So
yes,
that's
yes.
why that is what we are using basically. Yeah. So yeah. So yeah. What about third and fourth? If you want to disprove something, you can simply come up with a continuous function which doesn't satisfy this property.
Third option is not true. We can take if t equal to 1 for all t.
Okay. So you are saying third option is not true because we can take the constant function 1, which you can take. You should look at the conditions. According to the condition, we can take because it satisfies all the properties. Yes, if f of t is equal to 1, integral minus 1 to 1 f of t is 2, right? Because the length of the interval minus 1, 1 is 2. So you cannot find any x such that basically 1 equal to 2, which is not true. So yeah, this is, so third option is not true. So it should be a correct, I mean, answer to this problem. So it's that's how generally this how you come up with, you try to put some examples and see whether it is true first. Maybe that statement is true, but what if it is not true? So this is how you eliminate some options. So how about the last? Any idea?
So e to the power x.
Okay. So I take f of x is e to the power x. So what's your point? So if I take f of x equal to e to the power 0 to 1 f of x, f of t is e power t, what you get is e minus 1, right? So the question is whether this has a solution or not, which has, right? E raised to x. So this is a positive number. So e raised to x is a range of e raised to x is positive real line. So in the case when if you take f of x e raised to x, this statement is true. There will be an x, real number x such that this satisfies. I hope you got the point. You can't take e raised to x here. You got it, or
Yes, sir, yes, sir.
yeah. So e raised to x won't work. Maybe this is true. So that also you can try some examples also. Yeah. So if you are not aware of this, I will tell you. So this statement is actually true. So I'll tell you why is that. This is again by intermediate value property and using some facts about continuous functions, which is, so what is this all about? So f is a function from r to 0 infinity. So when you restrict f to closed interval 0 1, okay, So if we restrict, what you know about these things, continuous functions on closed interval AB. So what all things it is bounded, it has a maximum and minimum, right?
Sir, if we apply mean value theorem of integral calculus.
Yeah, I am talking about that
First
result only.
mean value theorem.
Yeah, mean value theorem for integral. So this statement, the statement which I am going to say was mean value theorem of integrals. If someone
It
is
gives
not aware,
fx equal to fc.
yeah. So I'm talking about So why is it true? So I'm kind of giving some proof of it. So this f restricted to 0, 1 has a maximum, right? Maximum and minimum. Is it? Because we are considering f on 0, 1, closed interval 0, 1. Because we only need to consider function on 0, 1 as it suggests. So that means m less than or equal to f of t less than equal to m for all t in 0, 1. Now integral also holds the same inequality, right? You have studied properties of integrals. So this says that in fact this number that lies between maximum and minimum. So the number which is given on the right hand side, this is a number which lies between the minimum and maximum of the function on 0, 1. So can you say now whether there will be exist an R such that f of x is this?
Yes, it is true.
Right, by intermediate value theorem. So yeah, so I will write a general version of this, but this is true. This is a true statement. So generally this is what happens. So this is called mean value theorem for integrals. So this you must have seen this, but just recalling it. So this is continuous. Then there is x in AB such that this is the mean value theorem for it. Same way you can prove. I proved it for 0, 1. So in the case when in our case interval is 0, 1. So this A is 0, B is 1. So it's like basically this is the average of this function on this interval. So f of x, you can get f of x 1 by 1 minus 0 integral 0 to 1 f of t. I'm just saying a general statement. This is called mean value theorem for integrals. It is proved in the same way as we did here. This way. So you can see that in general. So yeah. So that is a true statement. So the idea is you recall this mean value theorem for integrals, you can show that. So this last statement is true. So it cannot be taken as an answer to this problem. So this only one answer is correct, one option. Is it fine? If not, please ask. Yeah. Now, we can solve another problem. So again, some problem. F from R to R conditions are very important. Differentiable. F of 0 is 1. F dash x is given to be satisfying this inequality. What is the question? You need to know what is the maximum possible value of f of 1. So what is given to you is f is differentiable and f at some value is given, that is f of 0 is 1, it is given, and you have given some information on derivative of the function. So some inequality is given. So using this, can you get some information of f of 1 or say some other point, any point? I mean, can you get some inequality from this? How do you get some information on value of a function at some point using this inequality of derivatives and all? I mean, any result, you know. So I draw the graph. At 0 they have given 1, right? F of 0 is 1. They're asking about f of, sorry, they're asking about what is the value at okay, 1 I am writing it little deeper. So they are asking about what's the value here. The condition they have given is derivative is less than equal to 9. So that means f dash x, maybe you can say lies between -9 and n, because so in a way f dash x is a slope, right? So f dash x is slope. The slope of the it's at each point is less than or equal to 9. That's what they are saying. So what result will tell you some information on value at f of 1, say? Any
Lipschitz content.
what? I didn't hear. Can you repeat?
Derivative is bounded, so it is mod fx minus fy will be less than
So
or
you are
equal
saying
to,
it is Lipschitz function,
yes.
but using that, how do we talk about f of 1? Okay, suppose, yeah, whatever you are saying is correct. You will get this thing. You can prove it. So using it, how do we get information about f of 1? F of 0 1 is given.
Then mod f of 1 minus f of 0 will be less than or equal
Yes, so
to,
you put 1 and 0, right, in the values. I mean, x and in
yes,
place of
sir.
x and y, because that's what we want. We want f of 1. We know about f of 0. So you put x equal to 1 and y equal to 0 and see what happens. I will give you a simpler answer, but yeah, this is, in fact, we don't need to prove this much. But since you said it, we can 9 into 1 minus 0. So that means we get f of 1 minus 1 less than equal to 9. That means we only need the maximum possible value. So isn't it? So f of 1 lies between 10 and I think -8. Isn't it? Isn't this we are getting? So yeah, just so this is not required in this case, but yeah, if you know that, it's fine. This is good. So what I was trying to say, use mean value theorem. It's just a simple application to mean value theorem. So means you know the value at 0, you need a value at 1. So what by mean value theorem, what you know is f of 1 minus f of 0 by 1 minus 0 if f dash c for some c in between 0 and 1, right? So by the condition given, this is less than equal to 9. So that means f of 1 minus f of 0, which is 1, is less than equal to 9. So from that you get f of 1 less than equal to 10. That way also you can see. What she said is something, she's proved something stronger than this. Yeah, but that is good. Maybe in some problem it will help you. So this inequality too. So what we got is this or this. What we only need maximum possible value. So we don't need the left hand side inequality. Yeah. So what we got is f of 1 less than 10. So what will be the answer? Answer to the problem?
10.
Yes, but have we proved that there is a function having this property? is what we want is possible value, maximum possible value of f of 1. That means there should be a function which having all these properties in which f of 1 is 10. Then only you can say 10 is achieved, right? Otherwise, what we proved is if such a function is there, we proved that f of 1 is less than equal to 10. So that means f of 1 can be 10 or 9 or whatever less than 10. We should, it's our job is our job to ensure that there is at least one function having this property. Then only you can say the answer is 10. Right?
We
So
can take 9x plus 1.
What is the function?
9x plus 1.
Yeah. So what made you think that way? Like it's natural, right? So it is because for those of you wondering why 9x plus 1 suddenly. So at 0 it is 1. So what she did is the function with the maximum slope, 9 slope. So what we know is f dash x is less than 9, right? So we go for the function with the maximum slope, f dash x is 9. That's the line with slope 9, this line. So this what is, if you look for this function, this will be 9x plus 1. So yeah, f of x equal to 9x plus 1 satisfies this property, all these properties, and f of 1 is 10 there. So it is attained at for some function at least. That is why, so we proved that any function satisfying those properties satisfies f of 1 less than equal to 10. Also, we came up with a function which satisfies f of 1 equal to 10. That is why the answer is 10. Otherwise, maybe there does not exist such a function. Then we can't say 10 is the maximum value. Maybe 9 is the maximum value. We don't know. So it's our job is to ensure that there is at least one such function. I hope you got the point. So I will move on to another problem. So this is a limit evaluation problem. So by this symbol, I mean this floor function, greatest integer function. Okay, so how, any idea how to, I mean, it's not, I won't say it's very trivial, but we want to calculate the limit of each of these x. So how about each term by term? Maybe we can look x1 by x, x2 by x, and so on. So say first of all, x1 by x I'm taking. What is your expectation? I mean, if you don't have the answer, but still, can you guess it where it will be? Because it's floor function. So you know one thing, which is this. What will be the difference between t and this floor function of t? It's not too far away from t, right? This floor function of t means it always lies between 0 and 1. We can always, right? Means what I'm saying is I am expecting something like this, because 1 by x and floor function of 1 by x, it's not very far away, like, right? That's why I said this statement. It's very close, not very close in the sense its difference is always bounded between 0 and 1. So I somehow expect this kind of things to happen. I mean, I'm not sure, I'm not proving it, I'm just expecting. So you should have a feel of it when you see these kind of limit problems. You should guess it first, then try to prove it. So I'm expecting it because of this thing. Now I don't, so means x into 1 by x is 1. So I'm expecting the limit to be 1. So but it's not the correct argument. So how do I argue? What can I use here? So See, this is not, see, this is not exactly equal to 1 by x, but you know some inequality related to numbers, right? See, t and, do you know any inequality? I mean, not know what I said it already, but we just need to come up with that. I mean, I told you t and floor function of t is not far away. So in fact, you have this, right? T be any real number, always floor function of t lies between t minus 1 and t, right? Is it true?
Yes, sir.
So why I said it is because of that. The t and floor function of t is not very far away. It's close. That's why I am doing it. So maybe I can use this to get some information, because I am guessing 1 by x, floor function of 1 by x is similar to 1 by x. So I will replace t with the 1 by x. So I have this inequality. This is true for all x, because the right hand side is true for all t, right? So now I want information about x into floor function of 1 by x. So what should I do here in this inequality? I want this x into 1 by x, floor function of 1 by x. Okay, multiply by x. So first of all, we are considering limits, right? So, and in fact, we are considering limit from x tends to the 0 plus, means right side of 0, means we are considering only positive values of x. So, see, when we simply say multiply, the inequality need not hold, right? Because if x is negative, the inequality will reverse, right? But because we are considering limit of x tends to 0 plus, we only need to worry about values in x greater than 0. So this inequality will hold. And in fact, there is one more thing which you need to take care, which is this thing, means this could be negative, right? 1 by x minus 1. So when is it negative and when is it positive? So when x is bigger than 1, this is negative. But we don't care about what happens when x is greater than 1, because we are looking at limit of x tends to 0. So we only need to worry about what happens in a neighborhood of 0. So when x is between 0 and 1, these are positive quantities. These are positive quantities. So this inequality makes sense. So then only you can say this inequality is true. See, when you, for this entrance exam, you can get rid of it. You can get away with that. But if you are actually writing the proof, you should be careful about these details. Because this inequality is not true for every x. Because we only need to worry about limit x tends to 0 plus, we only need to worry about what happens in a neighborhood of 0, in a positive side. So here we have this inequality. So I just want to stress on this point, that this inequality is not true everywhere. So now for problem solving, it's not a big deal. You will get away with that. You will get the final correct answer finally. But yeah, your argument should be perfect, right? So what you get is 1 minus x less than x times 1 by x is less than or equal to 1. Isn't it? That's what you are getting. For all 0 less than x less than 1. We don't need to worry about what happens outside x 0 and 1, because we are looking at limit of x tends to 0 plus. So now, can you tell me what will be the limit of this thing?
1.
Yes, using what theorem?
Sandwich.
Yeah, skews theorem or sandwich theorem, because the left hand side tends to 1 as x tends to 0. This is already 1. So this is 1. right? So that means the limit of the first term x into 1 by x, this is actually 1. So I'm asking, what will be this value x into 2 by x limit? In a similar way you can do,
2.
it will be 2, right? Similarly, this will be x into 10 by x will be 10. So what will be the final answer? 1 plus 2 plus 3 plus etc. plus 10, right? So what we did is term by term we took, and we saw that there are 10 terms in which each term limit exists. So we found the limit of each term. So then we simply add them. So the idea is to how to see this, how to see why it is. That's why I gave you some idea why I expect it in this way. You know, x into floor function of 1 by x. I expected it to be something like x into 1 by x. It's not correct argument, but that's what we proved here using this inequality. Okay, I hope you got the point. So see, if I simply explain this inequality and then you will understand, but you won't understand why I did that. So that's why I gave you one reason. You should always have a guess of what the limit will be. So there should be some motivation towards it, towards writing it. So yeah, I hope you got the point. I mean, you may see it non-trivial if you are seeing these kind of things for the first time, which I was also like that when I was preparing. But the idea about this is you solve, you practice these kind of problems more and more, and finally you will get the idea how to approach when you get a problem. That's the idea. In the beginning, you may feel like, okay, this is very non-trivial to me. I'm not getting it. I don't know how I will solve when I get a new problem. That will be there, but that will be there for some time. You need to practice more and more. That's how you can learn. So I will go to next problem. So yeah, again, conditions are very important. F from R to R be differentiable. F of 0 is 0. And what is given? We define the sequence n f of 1 by n. N f of 1 by n. They are asking about the limit of the sequence. So in the conditions you can see they are given f is differentiable. So that means this has something to do with differentiability, not a problem on sequence. So, and in fact you can see that in the options it's related to derivative of the function. So how do you find the limit, or at least what all things are given is value of f at 0 is given, it is differentiable, some sequence is given, we want the limit of the sequence. Any idea? Or see, generally when you see such problem, you can try to get some examples and try to put it there and see what happens, so that maybe you can avoid neglect some options, you get the answer. So any idea? Or you can directly prove it, whichever.
So sequential criteria.
Yes, so you are going to prove it. So
We can say that f of 1 by n will also go to 0. So limit n tends to infinity and comes as f 0 by no f of 1 by n by 1 by n, and
so
we will have
that means you are writing it as f of 1 by n by 1 by n, right?
yes.
So something made you write that, right? No one, it's not someone told you to write it. Something in your brain tells you to write it in this way. Why you wrote it in this way? There should be a reason, right?
We want derivative, so
Exactly.
L'Hospital rule should come.
Yeah. right? So we want derivative. That's why you took that n to the denominator. So there should be a reason why we do that. So now, so what is the connection of this thing with derivative at 0? Is there any connection? So f of 0 is given to be 0. So what is f dash 0 by definition? F dash 0 is limit so x tends to 0 f of x minus f of 0 by. Is it of this form, the limit we are talking about? Because what is f of 0 in our case? 0, right? So this is of this form, right? The sequence which we are talking about is we identified that it is of the form 1 f of 1 by n minus f of 0 divided by 1 by n, where this 1 by n is a sequence converging to 0. So by sequential criterion, as she said, this is the limit of, this is the same of the limit, this limit. And by the condition given that function is differentiable, it is differentiable at 0. So that limit exists, and that limit should be f dash 0. I hope you got the point, right? So we approach through the sequence 1 by n. So we use everything. We use the fact that in fact we don't need a function to be differentiable everywhere. We just need function to be differentiable at 0. I mean, so yeah. So seeing this may not give you anything, but yeah, there is some connection with derivative which gives you some idea. Like she said, you take n to the denominator. That's how you see that the limit should be f dash 0. I mean, this is not equal. I mean tends to f dash 0. How tends? Because f dash 0 is limit x tends to 0 f of x. So by sequential criterion, we approach through, say, a sequence 1 by n. You get f of 1 by n minus f of 0 by 1 by n tends to the same limit, which is f dash 0. That's what we have. I hope you got the answer, got the idea. So yeah, we proved it. In fact, you can come up with some examples and eliminate also, but in the exam you can do that, but when you practice it, you have to address each and every option. You should know how to prove it. So we have proved it. In fact, you can see if you consider the function f of x equal to x, so it satisfies all the conditions, right? Now what is n? N into f of 1 by n, that is n into 1 by n, which is 1. But then you can eliminate this option, right? So in that way, if this is asked in actual exam, you can directly write it, but you should always know how to prove it. Okay, so yeah, so the answer is f dash 0. I hope you got the idea. Can I move on to the next problem? Yes. So yeah, this is one problem which is given that G is given to be continuous on R. F is defined in the following way: integral 1 by x to x g of t dt when x is positive. Means we only consider f on the positive real line. Now it is given that f dash half is k times f dash 2. Then they are asking about value of k. So we need to know some information about f dash x. So what we know is this only. Can you find f dash x from here? I mean, is there any way in general?
Leibniz theorem.
Okay, you know some result. So yeah, so maybe I will recall it. So Leibniz theorem or something. So some result which is, this is actually proved by using the fundamental theorem of calculus. So in general, this is how this goes. So I'm not writing the full condition just for you to understand. So this is say I of x, some function I of x, f of t dt. Suppose you have a function of this form. I'm defining this as, then the derivative is given by, can anyone tell me what it is? So it should be differentiable. This upper limit phi of
Del
x and psi of x and differentiable.
del integration
Is there an integral sign there?
oh no.
Okay. So it should be phi
dash x f of phi x is
minus so this is the result. This is the formula. Now, I mean, see, for those of you wondering how this came, I can tell you. So this is, maybe I will take one more page. So you know the fundamental theorem of calculus, right? So if you have f continuous, I'm not writing full sentence. So on say a, b, and you define this function integral a to x. So what does fundamental theorem of calculus says? F dash x is f of x, right? So this is the fundamental theorem of calculus, but here it's more something more general. Here instead of the lower limit a, and which is a constant, and x, here you have general functions. It could be any differential function. So the idea is simple. So what you do is, so in general, suppose you have, see, this can be written as, I'm giving some outline of the proof, not exact proof, but this is true, right? This integral psi of x to phi of x, I will split it into two as a to phi of x minus a to psi of x. So now I need to differentiate this. So in order to differentiate the left hand side, I need to differentiate each two terms. Now how will I differentiate these two terms? So this, so I will tell you how this can be differentiated. So see, this thing is nothing but f of phi of x, right? If f of x is this, it's just the composition of f with phi of x, right? We are basically just putting, instead of x, we are putting a phi of x, right? So f of x is this. In place of x, we are putting phi of x. That's what this. So it's not, this function is nothing but the composition of f and phi. Now, if you want to take the derivative, use the chain rule. This is f dash phi of x into phi dash x. Similarly, here also you get this. So what you get is f of phi of f dash phi of x is f of phi of x, phi dash x, minus f of phi into psi dash x, which is the formula you have here. I mean, this is how you prove it, and I'm just giving you some general idea. So this is proved by fundamental theorem of calculus, just extension of it, some generalization of it, you can say. So yeah, you just remember this result for your IIT JAM exam. You need all these things. So that's, so in our case, how can we find f dash x using this formula? Can you tell me what will be the value? So derivative of x 1 times g of x minus what?
minus of 1 by x square.
Yeah,
G.
derivative of 1 by x, then g of
G of
1 by x.
1 by x.
So you got g of x plus 1 by x square 0. So you got f dash x in terms of g. So this is, I just want to, I just included this problem just to address this result. This. So yeah, you got f dash x. Now the rest of the thing I think you can prove, because what is given to you, f dash half is k f dash 2, right? So you see what f dash 2 is here, g of 2 plus 1 by 4 g of half. What is f dash half? G of half plus 4 g of 2. Now you can see a natural connection between f dash 2 and f dash half, right? Means when I multiply 4 to the left hand side of this, is it? Yeah, right? Can you see that f dash half is nothing but 4 times f dash 2? Just simply when you
Yes.
multiply, right? So the required value is 4, right? So yeah, the rest of the problem you can do, but the idea, the result you need to know here is this Leibniz theorem. Yeah, this is how. Can I move to the other problem? I think yes. Okay, this is also a similar problem. So the conditions are very important. Okay, so I see, you may be wondering why this continuity is there. Continuity is required for the fundamental theorem of calculus, right? So yeah, every condition is important. Otherwise, you can't use all these results. So that is one thing to note. So here also f is some function, g is some function. Only thing is that g takes values only in positive line. Positive, g is a positive valued function, continuous, and some conditions are given. Some function given. What we need is the value of this. So using this, can you get any information about f using this equation? How do you extract some information about f from, I mean, this is an integral equation. So how do you take f from here? Because we need to know about f, right? F and g, in fact.
We can derivative both sides and then we will
Yes.
get.
And we know how to differentiate this kind of thing, right? So I can take derivative on both sides. So by the previous formula, you're going to get derivative of x cube plus x square is 3x square plus 2x times f of x cube plus x square minus 0. There won't be any other term, equal to 2x. This is the equation you are going to get when you differentiate on both sides. Now you got some information on f. Right. Now how about g? What is given on g is that 0 to g of x t square is 9 into x plus 1 whole cube. First of all, integral 0 to g of x t square is what? What is the integral of t square? Directly you can compute it, right? T cube by 3, right? So it is nothing but g of x whole cube by 3, which is given as that integral. You don't need to differentiate or anything here. That's what I mean to say, right? Which is 9 into x plus 1 whole cube. So in other words, g of x whole cube is 27x plus 1 whole cube. And you know that 27 is 3 cube. So you can directly write it. So,
excuse me.
yeah.
But g of 0 is not equal to 0. It's not given.
G of
0, we don't know. So that term also should be there, right?
where is it?
When we are integrating t square dt from 0 to g of x, this is equal to g of x whole cube by 3 minus g of 0 whole
No,
cube by
not
3.
G of 0. It is 0. You're putting 0 on t cube by 3.
Sorry.
Right. So this is what you're getting. So g of x whole cube is 3 times x plus 1 whole cube. Now what is g of x then? Can I write it as this? Can I? Is it true or?
True, sir.
What do you know about cubic function? So generally, see, if I am saying like this, say a square equal to b square, can I say a equal to b? No, right? It could be a equal to minus b. But for cubic, do you have this? You know this
Yes,
function
sir.
is 1 1, right? A cube function is 1 1. That is why, because g of x cube is 3 into x plus 1 whole cube, you can say g of x is 3 into x plus 1. Suppose that instead of cube 3, if suppose the power was 2, you can't say it, right? So yeah, I just want to point out that. So in this case, g of x is 3 into x plus 1. So you got g. Now nothing. You know g of half now. Now only point is to find f of 2 and f of 12. So how do you get f of 2 and f of 12 from this equation? Only information you know about of f is this.
1, sir.
Yes. What?
X equal to 1.
Yes. When you put x equal to 1, you get f of 2, right? From this equation. And what? How will you get f of 12?
X equals
Equal to
2.
2, sir.
Yes. The rest you can compute it, right? So you get f of 2, f of 12. From this you get g of 2. Then you compute it. Calculation I am not doing, but you should be very careful because this exam is only looking at what is the final product, final answer you are getting. They don't know how you arrived at it. So if you make a mistake at the last moment, it's your loss. So you should be very careful when you write the exam, like making computation. But yeah, this you can complete it. Okay, come to this. Yeah, so again, f is differentiable at one. Some limit you need to evaluate. Some limit is given. You can think about it, how you can approach it. Again, look at the conditions. Differentiability at 1 is given. For a reason, there should be some reason why it should be given. It has something to do with derivative at 1. And in fact, the option suggests that. So, and in fact, the terms in the limit also suggest that, because you are looking at f of 1 plus x, f of 1, right? So what should be the idea? How can we evaluate this limit? There is some power coming. So generally when powers come, what do you do? Is there any example?
Takes log, sir.
Yeah, there is a log method, right? So see, I'm calling this function say as g of x. So what you do is you look at log g of x, which is 1 by x log of this thing, which I can directly write it as using the property of log, right? Isn't it? When I apply log.
Yes, sir.
Now, yeah, I mean, why we apply log? Will it give something? Can we find the limit of this? So we are doing each approach. There is a reason why we are doing it, right? So we applied log. Why did we apply log? So You got something. Can
We
you
have
find the
got,
limit extends to 0?
we have got the 0 by 0 form, so we can use L'Hospital rule.
So why is it 0 by 0 form? When you put x tends to 0, yeah, you get log f of 1. It has something to do with continuity also, right? Because you cannot simply say log. When you apply limit x tends to 1, x tends to 0 on numerator, this tends to log f of 1 because f is continuous at 1. Because f is differentiable at 1. So we are using, and logarithm is continuous. We are using composition of continuous function is continuous. See, we are using all these things in the background. But the thing with these kind of entrance exam is that you can get away with that somehow. Without knowing these details, you can somehow get it. So it is because f is continuous. You can say it. So now it is of the form 0 by 0. Now, as you said, you can use L'Hospital rule. That is also fine. You will get it. But can you directly say is it of some form? This is directly derivative of something, right? If you can observe it carefully. This is 1 by x log. So in other words, what I am asking is this log f of
Derivative of log of g of x.
log of g of x or f of x. Our function is this. So limit x tends to 0, log f of 1 plus x minus log f of 1 by x. So isn't it the derivative of log f of x at 1? Are you able to see that? I mean, you can use that L'Hospital rule. Okay, I'm not against it. You can do that. You will get the answer. But I'm just directly saying this itself is a derivative of, right, log f of x, right? Are you able to see that? See, if I'm defining h of x as log f of x, what this limit says is it is h of 1 plus x minus h of 1 by x. This gives the derivative of x at 1, right? That is derivative of log f x at 1. I hope you got the point. So that means you can directly write this limit as the derivative of this function at 1. So what is derivative of this function at 1? That is going to be f dash 1 by f of 1. Or you can, as you said, L'Hospital rule is also fine. But yeah, so you get f dash 1. That is how this f dash 1 by f of 1 comes in the options. When you differentiate log f. So what we proved is that this limit is f dash 1 by f of 1. Which limit? Not the required limit. We first applied log and then found the limit, right? So we found the limit of the logarithm of the function which we needed. So what will be the limit? So limit of, exactly. So sometimes what happens is that we forget that, because maybe we are calculating it for we take 2-3 minutes or 3 to 5 minutes and we calculate it, and then we forget to take anti-log or exponential. It can happen, right? Because yeah, we may be doing lots of problems, so sometimes this happens. So you should be very careful when you do these things. So don't forget to take e to the power, because we found the limit of log g of x. What we need is the limit of g of x. So it will be e to the power f dash 1 by f. Again, there are reasons for it, because you can take limit inside and all. That is why you can do it. So there are reasons behind it, but I'm not stressing too much here, but you should be aware of it. Why limit of log g of x is f dash 1 by 1, then why limit of g of x should be e raised to, that is because logarithmic function is continuous. That continuity is what we are using. That's why you can take limit inside the log. So that's why you can do that. So, yeah, right now I'm not going to that much. So yeah, this is the answer. So the idea is to apply log and see what happens. So yeah, this is, we can, if you understood that, we can go to the next problem. This is a very interesting problem. So yeah, again, some conditions are there which you should be very careful what is given. So f from R to R continuous odd function. I hope you know what is odd function. So f is continuous. F is odd means
f of minus x equal to minus f of minus x.
yes. Another condition is that it vanishes exactly at one point. Okay. Means f of x is 0 only at one point. But can I ask you one thing, which is, if for a function, odd function, can I always say f is 0 at some point? Always. It's a property of an odd function.
f of 0 is 0.
Right. So if you put x equal to 0 on this equation, you get f of 0 is minus f of 0, which means f of 0 is 0. So it's a property of an odd function. F of 0 is always 0. So that means, so this condition suggests that what vanishes at exactly at one point, that exact one point is 0. So what we got is, we know f of 0 is 0 and f of 1 is half. That is also given. And we also know one thing, which is 0 is the only point having this property. That is also given. Now, these are the conditions. So once we observe all these, we can move on to start what is given. So given that f of x integral minus 1 to x small f of t dt, g of x minus 1 to x, see how it is defined, t mod f of t. So it's kind of complicated, but still it's not, don't need to worry too much. Now, and this is also given, limit x tends to 1 f of x by g of x. This is given to be 1 by 14. So there are so many conditions, but yeah, finally they are asking about f of half. So how do we use all these things to get this value of f at half? That's our question. So we can do it one by one. So now they have given this, no, this thing. So what is this limit if you expand it? This is integral minus 1 to x of t dt divided by integral some t. Yeah, for a moment I will write it as g of t, where g of t I am writing it as t times, and otherwise I have to write it every time. So that's why I am just denoting it by g of t. So g of t is t f of t, modulus of f of t. So now see, this value is given to be 1 by 14. That is okay, but can you apply the limit now on numerator and denominator and see what happens?
0 by 0 down.
Why is it 0 by 0 form? I mean,
ft is odd function, so minus 1 to 1 is 0.
yes. So
Integration.
I will tell you. So when you apply, you get this, right? This is how you apply actually. Because I need to stress on these details. I mean, as I said, you can get away with things, but still, when we do it, you should be doing it properly. So this is how you apply, right? Numerator and denominator. And are you saying that this is that what you're saying?
Yes.
Why is that, first of all, before going into what the value is 0? because limit extends to 1 minus 1 to x f of t. Why it is the value is when we replace x with 1. Means what are we using there to say that limit of this function is function evaluated at 1, right? We are using the fact that this function is continuous. So we should not miss that point. So that is by fundamental theorem of calculus, we know that since x is continuous, this thing is actually differentiable. That's what fundamental theorem of calculus is. So in particular, this is continuous. So limit extends to 1. This is in minus 1 to 1 f of t. Means putting x equal to 1. You got the point. So we are using the fact that this function is actually continuous. In fact, it is differentiable, but because of continuity, you can say that. Similarly, the denominator. That is why you can write it. So yeah. For problem solving, you may not you don't need to worry too much about it, but yeah, you need to you should know all these things. So yeah, now what is the limit? Integral minus 1 to 1 f of t. What do you know about it? So,
0.
Yeah, 0. Why? Because f is odd function, right? So
Yes.
wondering where will I write it. So I will take another page, but I have to write the same thing again. So I will write the main things which we got. So which we wrote. Now you said this is 0 because f is odd function. You know the property. Similarly, again, why I write this one? This is also need to be explained. Why this is when you apply limit. This is because g is continuous. So our g is this small g. Why g is continuous? Can you tell me? T into mod f of t. Why continuous? We only know f is continuous.
The composition of f and f is also continuous.
Yeah. We are using some composition idea, right? F of f is continuous, modulus is continuous, composing them continuous, so, and product of these two. So that is the reason. So it should be very clear. So g is continuous actually. So this is a continuous function. So that is why we can write this. Now, what about this integral minus 1 to 1 g of t dt? Can you say anything?
This is also odd function.
Yes, so that is another observation here. So that's why this problem is interesting. So many things to observe. So g of t is actually odd. Do I need to show it or you will check it? Because you use the fact that f is odd. So you can show that g of minus t is minus g of t. You put minus t on this, you can see that. So that observation need to be checked. So g is also continuous, g is also odd. So that is why this is also 0. That is how you got it is 0 by 0 form. Is it clear to everyone? So yeah, we are using so many things, but yeah, most of the things you can get away with that even if you don't know. But I'm just explaining each step. So now this is of the form 0 by 0. So what you will do?
Differentiate denominator and numerator.
Exactly. So by L'Hospital rule, we know that this is the same as f dash x by t dash. Now, what is f dash x? What is the
fx.
Exactly, because by the fundamental theorem of calculus, this fx, this is gx. Again by fundamental theorem of calculus. Now, can you apply this? What is limit extends to 1 f of x?
Yes, I can.
Because I will go back to the previous page. F of 1 is given to be half and f is continuous. So, limit extends to 1 f of x is f of 1. Similarly, g is continuous at 1, so g of 1. So, this is half. Sorry, what is given to us? No, f of, yeah, this is half by, what is g of 1? What is g or f? G of 1 is what?
F of half.
When you put?
F of half gives mod of f of half.
Yeah, so when you put g of 1 by, when you put t equal to 1, you get mod of f of 1, which is half by mod of f of, what is f of 1? That is half. So this is what you are getting as the answer, final answer. And can f of half be 0, the denominator?
No.
Can this be 0?
No, f of 0 equals to 0 exactly 1 point.
Exactly. So we are using every conditions. So it vanishes only at 1 point, and we know that it is at 0. So it can't be 0. That means this actually a non-zero number. So this makes sense. Now we are given that this value is what? 1 by 14,
1 by
right?
14.
Yes. So from that, what you get? Mod f of half is, I think, 7. Yeah. But what do you need? F of half, not mod f of half. So that means f of half, what are the possibilities? 7 or?
Plus minus 7.
But in this case, what should be f of half? Tell me. 7 or minus 7. Look at the conditions and tell me what should be f of half. Can it be 7? Can it be minus 7?
Minus 7, sir.
You are saying it should be minus 7. Why?
Because hot function, sir.
So, what functions have any such properties? So, I mean, just f of half is, suppose I am writing it, f of half is minus 7. What is f of?
No, it would be 7.
F of 1 is half, right? Right? Given. So, this is negative and this is positive.
Oh, this is not true.
Because f is continuous, by intermediate value theorem, between this half and 1, there should be an element. F of x is 0, right? By intermediate value theorem. But that can't be true. Right? We got a contradiction. I hope you got the point.
Yes, sir, got it.
Is it okay? If f of half is okay, just minus 7, then it is less than 0, and it is given that f of 1 is positive. So by f is continuous. So by intermediate value theorem, there should be an element between half and 1 which vanishes, right? But according to the conditions given, it can't be true, right? F can vanish only at 0. So this can't be true. So f of half cannot be minus 7. So the only possibility is f of half. Is it clear?
Yes, sir.
So this is a very interesting problem, which, so we have to use so many conditions which is given to you, like, so that, and the thing which we are doing is all that you know, right? All results that you know. The thing is that you have to do it, understand what is given to you, use it, use everything that is given to solve it. So this is how it's a nice problem, because we have to use a lot of facts. So now another problem, yeah, this looks like series kind of thing, but it's not related to that. But can you, okay, first of all, this by I mean again floor function. Okay, I'm just recalling. So what they're asking is what is the value of this number? Floor function of 1 plus 1 by 4th root of 2 plus 1 by 4th root of 3, etc. plus 1 by 9999 4th root. So we don't want the value of the inside part. Okay, that is one thing you should notice. What they're asking is what is the value of the greatest integer of this number, not the. So it should, that is one hint that I can give to you right now. Because if you try to find the value and then find the greatest integer, it's not going to work, because finding this value is not easy. Finding this sum is not easy in general. So that is one hint I can give to you. We don't really need this sum. What we need is a greatest integer of that. Means in a way, what we need is some number closer to it. In a way, we want some approximate value, not the exact value. So you got something, some idea? You don't want exact value, but can you get some approximate value of such a thing? You have any idea? This is some sum of certain things. So this is, I think you should be able to say, because this is sum of some things, but do you know of any approximation to it? Are you able to think of something? You can take your time, but so, yeah, that's the main idea. You don't need the exact value of this number. You only need some number closer to it. That's the first idea. Then you try to build through it. So anything come to your mind, you can just tell me. You don't need to worry about if it is wrong or anything. Just
The fourth root of unity.
fourth root of
Unity.
but why is it important here? Okay, I will give one word. Tell me whether you are getting. Okay, this is sum of something, right? Like, okay, I can see some chats also. Okay, I didn't see it. Yeah, P series, but it's not. But how do we get it? Like, we want an
It is not
approximation.
infinite series. It is finite series.
Yeah, it's a finite series. Yeah, even if it is infinite, we don't know the value, right? So you can't really do that. But yeah, see, I can tell you the answer, but you know, I want you to tell me. That is more good, because maybe I will.
Maybe we have to add all the integer parts of the every number, but I don't know how to do that.
That is complicated, right? And that is not true, right? In general, not like that. I'm talking about approximation. So this is what you say. Can you see this as sum of areas of something? Areas of some rectangles. Maybe now you get some idea.
They're using Riemann integrals.
Yes, exactly. So yeah, I want someone to say this. That's why I waited for this. But yeah, it's non-trivial. I can understand. It's not very obvious, but yeah, that is why I gave you from the beginning. We don't really want the exact value of this. We want only some number closer to it. That gives you something which approximates summation. What do you know which approximates summation? You learning it from 12th standard, right? Approximating summation. What do you learn? Which is the integration, right? So that connection you should have when you see this. Is it clear? I mean, no, I didn't explain the answer, but still, are you able to connect it with integration?
Yes, sir.
Yeah, that is the first thing which we need. Then later we can try to get the answer. So now how do we connect it with the, so see this as a Riemann sum of something. This is Riemann sum of what? Which function should I take? F of x?
1 by x to the power 1 by 4.
Exactly, natural. This is the function I need to consider. I need to integrate this function from some limit to some limit, which we will see from this. So I will try to, okay, I will try to draw this. So how does 1 by x power 1 by 4 looks like? So we are going to draw this thing. I mean, you don't need to say the exact way. It is decreasing, right, on positive line. It will be like 1 by x, right? Just want to that. So very bad at drawing, but yeah, I will not draw the correct way, but yeah, this is going to 0 actually, right? As x tends to infinity. That's the curve. So 0, 1, 2, 3, and so on up to 9999, right? That's the last number which we consider. This is next number is 10,000. I will write until that. Now we'll see. So okay, so f of is f of 1. So in between, I'm not drawing. I can't draw everything, right? So
Sir, I think it should be take a left hand one because it starts from 1.
which one are you saying? F of, so yeah, I'm telling what is this area like. So this is f of 1, right? Area of that rectangle. Any doubt? Because see the height which I'm taking is f of 1 level. This is f of 2 because this is f of 2, right? Just straight to 2. Are you able to see that?
Yes, sir.
Similarly, so area of this rectangle is f of 1, f of 2, right? So this is f of 9, 8. So this sum which we needed. So which is bigger, integral or the sum of rectangles? You have taken upper sum, right? So integral 1 to say 10,000. This is bigger or the sum is bigger? That
Sum is bigger.
Sum is bigger, right? Because what is this? This is the area under the curve, right? So rectangle is, see, in between this area also is there. We have to draw rectangle. I mean, I didn't draw it, but yeah. So what we have is, this is the quantity we are looking for, right? The right hand side. So I hope you got the idea.
Yes, sir. Yes.
Similarly, you can consider lower sum also. So this way, this is lower sum. This smaller rectangle, the below one. So maybe here, I may not be drawing the right way, but so you get, finally, this is how what you're going to get. You get lower sum. What will be lower sum? It will start from f of 2. I mean, you can work it out. I mean, I am just writing it. I don't know whether 999
plus 1 by
yeah
10
this
0 0.
yeah, okay, this is fine. This is less than or equal to integral 1 to 10,000 less than or equal to 1 plus, this is the quantity we need. So we know some inequality. So that means this integral lies between these two numbers. Now, can you compute this integral? Integral 1 to 1 by x power 1 by 4. What will happen? You know how to integrate this, right? X 1 by x power 1 by 4. Right? X power minus 1 by 4. So you know how to integrate x, any x power anything.
X power minus 3 by 4
Yeah.
divided by
Yeah.
minus 3.
So I think you get 3 by 4, right? So 4 by 3 x power 3 by 4. Is it what you are getting? You have to check it. Just integrate it. I mean, integration you have to do, and that you must know. It is 4 by 3 times. What is 10,000 power 3 by 4? What is the fourth root of 10,000? That is where
10.
this number, yeah, that is why this number is important. We can easily calculate it. That is why they have given 9999. So, yeah, 10,000 power 3 by 4 is, it's a fourth root cube, right? So, it is 10 cube. Is it clear? 10,000 power 3 by 4 is 10,000 power 1 by 4 whole cube. That is 10 cube. It is. So, you get is 4 by 3 times 3, sorry, 999. This is 4 into 333, which is, I think, 1332. So this number is 1332. In fact, you can look at the options. This thing is there. Others are very far away, right? Options. So you can directly write this, but when you do it now, we have to be careful why it should be like that. From the options, the other numbers are far away from 1332. So that will suggest you that this should be the answer. So yeah, when we do it now, we have to do it carefully. So what we proved is this is the number we want. We showed that it is less greater than or equal to 1332. Also, the lower sum, this thing. So from this, can you say greatest integer of this is 1332? The thing is, this thing is very close to the right hand side. Right? If you look at the difference between the right side term and left side term, it's very small, right? In fact, I think, yeah, it's less than 1, right? You can simply subtract it. Only if 2 terms will remain. So this and this are very close to each other. It means its difference is less than 1, and there is an integer here in between. So that means this is the greatest integer less than or equal to this number, right? There cannot be any integer in between. I mean, if you are confused, you can check it. I mean, that you can think about it. So yeah, the main idea. So see, the proper explanation is taken time, but when you do it, you just need to compute this integral basically. This integral is giving you the answer 1332. That's it. You can simply write this. The answer will be 1 to 10,000 1 by 4. This is the answer basically. But yeah, if you want to properly argue, this is how you. Yeah, if you didn't get the calculation part, you can think about it. You can do it. I mean, yeah, it's not that much difficult. So I want you to know whether the idea is clear.
Yes, sir.
Yeah. So I think the time is going. So I will try to solve one more problem or something. I want to find some good problem. Yeah, maybe I will do one more problem on integration. There are other problems, but yeah, we don't have time. So you look, see the question, set of all continuous functions f from 0 1 to r that satisfy this property. Then they are asking about the cardinality of the set. Means they are asking how many such functions are there. So this means there are no such functions. There is only one such function. There is only 2 functions, or there is more than 2 functions. We need to see. So again, the conditions are very important. We are looking for continuous function satisfying this property. So this property is like too much, right? It's very like it's not very looking good. But is there any natural idea you are getting to approach this? So if you have already seen it, I don't want that answer, because if you have already seen this somewhere and then feeling, then others won't feel comfortable. So I want someone who has not seen this, who is seeing this problem for the first time to answer. I mean, give some inputs. So so what do you know? What you know is f is continuous. Also, it satisfies this integral 0 to 1. Yeah, this says something. F of x into 1 minus f of x is 1 by 4. So what does this has to do? Like, so this is of the form f of x into 1 minus f of x. That is y into 1 minus y form, right? y into, see, this is of the form y into 1 minus y, where y is replaced by f of x, right? So do you know anything about this function? So what is this? This is nothing but y minus y square. This is a quadratic polynomial. So what do you know about this function? In the sense, see, what do you know means you can say so many things, but I'm not asking that, but which is relevant to this problem. So I mean, in some sense, I am asking, does it have maximum or minimum kind of? Can you tell me whether it has a maximum or minimum? So this is a quadratic polynomial. You know this, how this graph looks like, right? These kind of functions. It's a parabola, right? It has a maximum or minimum. How does it look like?
It will have a maximum at half.
Yeah, so it's a downward facing parabola. That's what I want to, I mean, you should have some geometrical idea about these kind of functions. So when you see this quadratic polynomial, you should have this idea. So why I am saying is that I will tell you, but so the function inside the integral has this form. So that is one thing we need to observe. It is of the form f of x into 1 minus f of x. Means it is of the form y into 1 minus y. You know that this function, it is going to minus infinity, but it has a maximum. And can you tell me where is it exactly maximum? You said y equal to half. You said it by maybe by differentiating it and taking the critical point. That is fine. So at y equal to half, this function attains maximum. So in general, this is the case. When you have a quadratic polynomial and the leading coefficient is negative, it will be a polynomial going downwards like this. So it will always have a maximum. If the leading coefficient is positive, it will be going like this. So it will have a minimum. So this thing you should know every time. So at half, it attains maximum. And what is the maximum value? It is saying something to you. What is the value at half?
1 by 4.
Yes. 1 by 4, right? So it attains the value, the maximum value this can take is 1 by 4. You got it? Means this function can take, the maximum value it can take is 1 by 4. So that means maximum value, this thing, the thing inside the integral can take is 1 by 4. You got the point? Is it clear that f of x times 1 minus f of x, it can take, this is true for all x. Because anything of this form will be less than 1 by 4. That's what we saw. That identification is very important here. That's a trick here. I mean, so you will be wondering why this condition is given. Why this function f of x into 1 minus f of x? Why is it important? Yeah. So this, if you observe this, now can you give the answer? How many such functions are there? So maybe I'll write in the another page. So we know that f of x into 1 minus f of x. So that means integral 0 to 1 integration has this property, which is 1 by 4. So in general, this is less than 1 by 4. What is given is, we want to find the function which satisfies this integral equal to 1 by 4. In general, this is less than 1 by 4. So I'm asking for what all functions with this will be equal, strictly equal to 1 by 4. Yeah, someone says constant function. Yes, why is that? We are using continuity and everything. So that's the important thing. So geometrically, this is how it looks like. So this is 0, this is 1. Say this is 1/4. This is the line 1/4. Okay. Now we know that f of x into 1. I'm drawing the graph of f of x equal f of x into 1 minus f of x. This inequality suggests that your curve lies below this line, right? Below 1/4, isn't it? I just want an answer. Means we know that f of x into 1 minus f of x is less than or equal to 1/4. So that means this curve, if you draw, it is always below 1/4, right? It will be somewhere here. Is it clear? It cannot be going above 1/4. Isn't it? So now you want the integral under this curve to be exactly 1/4. See, 1/4 is the area of this whole rectangle, right? So in order for that both area to be equal, what do you want? This function should be constant, right? We are using some facts, but is it clear? This f of x times 1 minus f of this function should be 1/4, right? Because you use the continuity. Suppose it is not 1/4. Suppose it is less than 1/4 at some point. Then by continuity you can find a neighborhood of this in which this is less than 1/4. So you get a neighborhood where it's not touching this. It's not. You remove a non-zero region area, right? So the function has to be the constant function 1/4. We are not talking about f of x. We are talking about f of x times 1 minus f of x. It has to be 1/4, right? If it is less than 1/4 at some point, then by continuity you can argue that the integral will be strictly less than 1/4. So in order for this equality to hold, the integral equality, integral 0 to 1 f of x 1 minus f of x is 1/4. You want this function to be exactly equal to 1/4 for every x. Is it clear until now? Why it should be equal to 1/4? Because we know that it's less than or equal to 1/4. And we also want integral to be strictly equal to 1/4. So you use the continuity, basically, continuity of f to say that this is continuous. So is it clear? Or is there any doubt?
Yeah.
Clear, sir.
Okay. Now, so we got f of x into 1 minus f of x is exactly equal to 1/4. That's the relation we got. Now, what do you need is f of x, right? We need to find f of x. Can you find f of x from here?
F of x equals to half.
Why is that? Why anything else can't be?
No. A
Because
simplification. Just.
Yeah. Exactly. So yeah, we can simplify it and you can see, right? So you can see, in fact, what you are doing is you can solve this equation, right? This is a quadratic equation in f of x.
Yes.
Right? F of x minus f of x whole square equal to 1/4. Solve this equation, you will get f of x equal to half. There is only one root. This half root is repeated. So that means this implies f of x equal to half. And in fact, you can check whether f of x equal to half works or not in the equation. So f of x equal to half. So integral 0 to 1 half into 1 minus half is 1/4. So it is correct. You also have to verify it because maybe somewhere it is wrong. So that means what we proved is that if some function satisfies this property, then f of x has to be half. And in fact, we verified that f of x equal to half satisfies this. So that means how many functions satisfy this? Only one function, which is f of x equal to half. Is it clear? See, these kind of ideas will be, yeah, as I said earlier, it will be non-trivial to you if you are seeing these kind of ideas for the first time. But see, this is how you learn by solving more and more problems. This is how you learn how to do. So that's if you're seeing it, this kind of things for the first time, it's just for the first time. You keep using it for a long time and do similar problems, you will be able to do things like that. So maybe I will stop here with this. And if you have any doubts or anything, you can ask. I will.
Okay, thank you, Anand. Thank you for this nice session with a good collection of problems from real analysis.
Hello, good afternoon, sir.
Yeah.
My name is Gauri, and I'm from St. Teresa's College, Ernakulam. Sir, it's like it would be have been my loss if I couldn't attend this session. It was a very nice and interactive session. The way you took the class and the way you selected the questions, which you had to solve here and teach us here, like it was a really great experience for us, especially when the dates of the JAM exam is approaching us. It would like we could really make out of the time. The time was like the time spent was really helpful for us. And thank you for spending your valuable time and knowledge with us. And special thanks to Vinod sir for creating such a great session for us. Thank you, sir.
Thank you. Thank you so much.
Sir, can you please send a PDF of your collected question?
Good afternoon, sir. I am Dharmendra from Kasganj. This session was very nice and very higher level problems and some related to flow function was very nice, and second last problem was very nice also. That was easy but things too difficult. So I want to ask which book you can suggest and for problem and reference, other reference, or can you share these problems with him also, remaining problems? Thank you, sir.
Yeah. So yeah, you want to know about the references or some?
Yeah, sir. Reference textbook.
Yeah, for problems, I will say, see, we did some limit evaluation problems, right? Limits, all those things that you can try from this maybe Thomas calculus textbooks. I mean, this evaluation problem, limit evaluation, not it's computational type problems. You can see a lot of problems. You can get a lot of problems from these Thomas calculus and all. Otherwise, if you're looking for more, then yeah, you can get it from there is some book called Problems in Mathematical Analysis. There are 3 volumes of it, which I don't know, but I have heard from my friends that it is good for analysis problems. So they have divided into 3 volumes. So in each volume, I think the first volume they talk about limits, continuity, those things, then go to integration kind of. So that might help. I think it's called Problems in Mathematical Analysis. So that will be also helpful for doing problems in analysis, real analysis and all. Also, you see, if you want to see these conceptual problems, then you read this. Here, beginner level, you can see Bartle, and in fact, there is a book by.
Yeah.
There is a book by Kummeration, a basic course in real analysis. That's a very good book for if you are a beginner, if you want to understand real analysis. It's a very good book. You need to solve exercises also, but yeah, if you are able to do it, then your concept will be very precise, very clear. And in order to solve these problems, obviously you need to practice a lot. It won't come soon. You need to do a lot of practice. That's how you can get it. In fact, that's how, from my experience, I'm telling you, I cleared jam because of I I practiced a lot of problems. In fact, I can't even give a count of how many problems I solved, because that's how only I think I cleared jam. So many see, the problems is like, see, that's what I said when we were explaining. You may find it non-trivial, the tricks or things that are used, but if you keep on using this again and again, that's how you get these things. It will be useful to you in a later problem. So the things which you are using is maybe new to you in the beginning, but then later it comes to you naturally. That's how you learn, right? You do it, you learn by doing it. So yeah, that's my advice to all of you for preparing for these kind of exams.
Yes, sir. Yes. Sir, can you share your research experience?
Research experience?
Yeah, sir.
Is that what? Okay. Yeah, I am currently in my, I just finished my 2 years. So I just completed my coursework and then just started doing research. Not much experience, I can't say. I am reading some papers and I'm working on some certain problems. Not much I have done so far. So
Yeah, thank you, Dharmendra, for this.
Hello, hello,
yeah.
sir. Sir, I
Yes.
am Dia. I am doing my MSc second year from IIT Bhubaneswar. Sir, today's class was really great. You have explained all the concepts behind the problems also. Sir, I want to know one thing. Can you share us with us about your PhD interview experience?
Yeah. So in fact, when I joined in 2020, so it was online. But yeah, it didn't take too much time. But I will tell you how generally PhD interview goes. So it will be like they will start. You will be having your favorite area topic, or maybe not one topic, maybe one or two topics. So they will ask you what are your interests and all. So according to that, they will start asking questions from there. So it will be basic from the beginning. So in my case, what happened is that it was online. They didn't get much time, so they just directly started asking something. So generally, what happens is that they start asking some definition of something, then they build from there. So what I felt is that they randomly ask some things. They are professors, right? So they have many questions related to each concepts. So they start with asking, okay, what is Riemann integration? Define it. So you define it. Then they will start asking something related to. I mean, I can't say an example because it could be anything. They can ask anything. That's the thing with interviews. So the idea is like you need to be thorough with the concepts by reading textbooks and all. That's how you can learn. You don't. The thing with interviews is that you don't need to worry about these kind of problems. I mean, concept that's computational type. That things only required for your these kind of exams, but here, yeah, this is how generally interviews goes. They will start asking some statements. They will ask some theorem. They might ask if in that theorem, if we remove some conditions, what happens? Whether it is true or not. Do we have any counter examples? So these kind of things. And also another thing I observed from interviews is that you you don't sometimes you don't need to give the precise or exact answer. They will help you. They will they will give you hints to answer. It's not that they will ask and they will be silent. You have to answer everything. Most of them, what I have observed is they are very happy to help. So it's that we need to give some input first. So they will give some hint sometimes. So using that hint, how you use that hint to give the answer. It's all about that. So what they will be looking at more or less like how you use those things to answer it. What is the way of thinking? That's what they are thinking. That's what they are looking at. So mainly that's generally this is how it goes. So it depends on the institute how they ask, but yeah, generally this is how they will ask questions in interviews.
Okay, sir. Thank you, sir.
Good afternoon, sir. I am Shikha, second year MSc student from Birla Institute of Technology, Meshra, Jharkhand. So your session was really nice, and it was you explained each and every question very well, and it was easy to understand us. Sir, I wanted to know your approach for preparing CSIR net, like how you have started, how you have planned your schedule for. Actually, I used to face lots of problem in analysis portion, so I wanted to know your preparation strategy.
So I will say for just a minute. Yeah, so I will say for CSIR, is there any echo kind of thing? No, right? No issue with the sound?
It's okay now.
Okay. So for CSIR, I will say I didn't do much preparation because I did a lot of preparation for IIT JAM. So from that, I know how to handle these kind of entrance examinations. No, so what I did for CSIR is that, like, I was in first semester that time, so I just started looking at problems from whatever area I can answer, because at that time I am only in first year or first semester, so I don't know much subjects. So I just looked at real analysis and linear algebra stuff, and mostly that's what I tried to solve. So what I did, I simply looked at the previous year problems and I started solving it. In fact, yeah, that is because I have experience in this writing these exams previously, because I have cleared JAM, so I know how it is. So maybe I will tell you how I looked at JAM, how I prepared for that. So that is how the general idea is, the problem solving, because that's what you need for these kind of exams. So see, you need to know the concept. That's important. You should know the results, but the thing is how to apply it when a problem is given to you. I mean, if a problem is given to you, suppose these are the results that you need to know to solve the problem. Suppose the result is also in your brain, but still what happens is that sometimes we don't know how it is to be applied to solve the problem. That's what generally people face. So this is achieved by solving, again and coming back to the same thing, so practicing more and more problems. So you will see in the beginning, you will see these kind of non-trivial things, which that is mainly because of our the way in which we study in college. In college you don't do these kind of problems, right? That's why we are not familiar with these kind of problems. That is why we are finding it new, or I will say it's not difficult, it's different from what you have seen. That's why you feel like this is different. So how to tackle this is by practicing a lot of problems. In between you feel like okay, these are non-trivial to me, how can I solve if I get some other problem? But this is achieved by, believe me, that's what I did. From my experience, I'm telling you, you keep on doing, practicing problems. Each time you are improving, each time you are getting something new from it. And in fact, this helps you in time management also, because this is very important example where time is very important, right? Time management is also very important. So practicing problems will help you all in all these departments, like how to solve a certain problem